This will be the review of the practice exam for our exit exam, which is our final. So, question 1 is, what does this become when we multiply it? So the method we'd use is the FOIL. So our first, and this would be the work you would show, x squared, your outers, 5xy, your inners, 9xy, and your last. Now notice you have two like terms in the middle, so this gives you x squared plus 14xy plus 45y squared. And now you're going to match it up. So x squared looks like this one right here. So you put a dot there to indicate that is your selected answer, and there you have results, the work of the FOIL. So that one's good. Let's go on to example 2. Now for number 2, as we look at it, we see they want us to factor. We're looking through each of these terms to see what's my greatest common factor. And it's 3 in terms of the number. And the letter, the greatest one you can take out of each one is m to the third. And checking the signs, this is what we get, and this is the answer. Now as we look at this one, there are 4 terms and they're asking us to factor it. So whenever we see factoring in which there are 4 terms, we look to see what technique we might use. Well, in this case it would be factoring by grouping, and we're going to see what we can take out of these first 2 here. So out of these first 2, I believe we can take an x squared. And then we get an x plus 4. Now out of these last 2, we want to see if we can get an x plus 4 out of there. And notice they're both negative. We need to change both signs. And to get that, we have to factor out a negative 8. And we distribute, and it makes sense. So now we take each of our factors here, put them in a parenthesis, and x plus 4 is a common factor of both of these. So now we look to see which one we have. This one? No. This one? No. Now notice the arrangement of this is the reverse of what I have here. But this is perfectly acceptable, and this is the answer. Now this step is crucial in your work. All right, let's go on. Now in this one, we have to decide what method will we use, because it's finding the 0. Well, as we showed in the other practice quiz, we have to put this in standard form. So what I could do is multiply everything here by a negative. It changes all their signs. So this becomes a negative, this becomes a plus, this becomes a negative, and rewrite it in standard form. So we reversed all the original signs by multiplying everything by a -1, and we get this that we're now going to factor. And this is the work you would need to show. And since our middle sign is negative, the larger will become negative. This is positive, so we have x equals -3 or x equals 6. X is -3, x equals 6. This is our answer. Here they're asking us to factor this. Is there a greatest common factor? No. So we're just going to put two sets of parentheses. Now, since our a term is prime, that makes it a little easier. But then we have to think of factors of 56. Now, the nice thing about multiple choices, they're giving us some hints here. It's going to be a 7 or an 8, I should say, or an 8 and a 7. You just have to figure it out. And the difference is 17. So let's take a look at one. And this is trial and error. So if this were an 8, 3 times 8 is 24. And if this is a 7, so 24 minus 7 gives me 17. So what will the signs be? Well, this middle term is negative, so this is going to be negative, and this will be positive. Now, it's okay that you kind of take a look at the multiple choice, because that's sort of a good deal, but you want to show the work a little bit like what I have here. That would be plenty. And of course you need to mark the answer. Now for this one, I don't know if you can see it, but these are perfect cubes, and they want to know the difference. So for this one, you're going to use our recipe where you put a parenthesis for 2 terms and a parenthesis for 3 terms. Then you look at your middle sign, that goes there, and then the opposite of this sign goes there for the middle term over here. Now you take the cube root of that, which is 4a, the cube root of that, which is 3b. Now you square this, that's 16a squared. Multiply these two together, you get 12ab. Then you disregard the sign because the other rule holds that if this is negative, this sign is positive. And then you square this term. And that is the recipe. So we look for this, 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 and this. This looks like the one here. Okay. Question 7. And notice I've given you an example of what the work should look like. Now on this one, wherever there's a y, we're going to substitute a -3. So 3 times -3 cubed plus 3 times -3 squared over -3 squared plus 6 times -3 minus 7. So wherever there was a y, we've put in a -3. And then we execute. -3 to the third is a -27. Plus, now a -3 squared is 9. So this will be 3 times 9. And then this is going to be a -3 times a -3 is a +9. This is going to be a -18 and a -7. So I'm showing lots of work as I take it step by step because I want to get this correct. So to save time, I multiplied this, got a -81. This gives me a +27. I added these together and got a -25. Then I subtracted this, and this was going to be a -54. Subtracted this, in a sense, got a -16. Negative by a negative made it a positive. And I see I could take a 2 out of each one, and it reduces to 27/8. 27/8. Again, this one is showing lots of work, but there's plenty of room to show it, and you want to get full credit, and this is what you need to show. Now, in this one, as you look at the example, the only thing they want you to do is to find the domain. We find the domain by looking at our denominator and determining what values in our denominator of x would make it 0. Well, we said we just equal the denominator to 0. You could write it out over here. So you get x plus 8 equals 0, or x minus 4 equals 0. So here we get x equals -8, x equals 4. So these are the values that if our denominator that contained the x had these values, it would make our denominator a 0. So these are excluded from the set of real numbers of our domain. Now, how do we write that in interval notation? Well, again, if you had trouble, you're looking for a way to do it, what numbers are we talking about? We're talking about a -8 on our number line and a +4. Now these values are excluded, so we would put like a hollow around them to indicate they are excluded. Now, how would we put this in interval notation? Keeping in mind the rest of this is all thickened here. Well, it's coming from -infinity here, going up to -8, but 8 is not included, so we put a parenthesis. We then put a union symbol saying it's starting from -8, but again, -8 is not included, up to 4. 4 is not included, and a union symbol again. Now the other side of 4 up to infinity, and that's our interval notation. So let's take a look at which one they have here, and it looks like this first one. Okay, we didn't have to look far. But again, I wasn't looking at the answers. I worked it out, and now that I have the answer, I'm just looking for the reporting of the answer, and this would be the work. Again, this little graph helps you put it into interval notation. Now here they're asking us to multiply, but again, they don't really want us to multiply. They want us to simplify, and we do that by factoring. Let me pause so we can save time. Well, there's all the factoring, and I foiled everything to check that I had it correct. Now what I need to do is find my ones. Well, anything divided by itself is 1. So now I'm left with k over k plus 4. K over k plus 4 right there. Now notice they didn't give you super hard examples. I haven't found anything super hard yet. Again, you need to know your techniques and again show the work. You would need to have the factoring in order to get credit for this answer. I'm seeing that some of these are in the practice quiz as well. We did one like this already. So we want to isolate our radical. We get the square root of 4x equals, as we transpose this, to 4. Now to get rid of the radical, we bring it to the same power as the index. So this then becomes the radicand. X equals 4. So again, once you know the technique, and this is the work to support your answer, the technique here will be to multiply our denominator by its conjugate. In fact, I should have written this out all by itself here too, so we have place to work here. So what is the conjugate? Well, we said the conjugate of anything is its opposite number, or I should say opposite sign. 5 plus 6i. 5 plus 6i. Now we are allowed to multiply anything by 1, which is what this is over itself. So let's just do that. So as we FOIL the bottom, 5 times 5 is 25. A negative times a positive is a negative. 6 times 6, 36 I squared. But keep in mind now that an I squared is a negative 1. So our denominator here is going to become a positive 36, which gives this a total of 61 as our denominator here. Now when I FOIL the top, I got a 25. My outers are a 30i, my inners a 10i. That gave me a 40i. And my last gave me a positive 12i, which I squared is a negative 1. So this is a negative 12. So this is going to give me a 13 here when I add these two together, plus 40i. Now, no example is written like this over here. This is not standard form, so I have to write it in standard form. 13 over 61 plus 40i over 61. So 13 plus, this looks like it right there. And again, this is the work you need to show that you've used the conjugate and get this answer. For this example, it's a quadratic equation, but it's not in standard form. And there's probably a couple of ways to do it. I'll show you one way, and again, show the work to support how you're doing it. So we're going to get 88z squared equals, I'm going to subtract a 3 from both sides. So I'm going to use the square root property, in which I'm going to divide both sides by 8. And I get c squared equals 121. Now, I've done this in my calculator already. And now I take the square root of this side, plus or minus the square root of this side. I get z equals plus or minus 11. Ooh, right there. Now, you could have put this in this form. 8z squared minus 968 equals 0. Factored an 8 out of each one. Get z squared minus 121 equals 0. And this factors into its conjugates. C plus 11, C minus 11, and you get the same results. Or you could have put it into the quadratic formula, which would have been rather tedious because these numbers are so big. Okay, but again, you need to show some work to support your answers. Again, this is a quadratic equation. It's in standard form. It's not going to be able to factor, but I'm going to use completing the square. This is what I did for the other one in the practice. So we go x squared minus 12x. And the reason I'm using completing the square is because my b term here is even. It's going to divide nicely. We take our c term, bring it over to the other side as a negative 61. Then we put a parenthesis squared, and we use that technique to complete the square. So this is x, half of this is 6. So now we're going to square the negative 6. This gives me a positive 36 that we're going to add to both sides. So again, this is now equal because we had this in blue, and we're just adding 36 to both sides. So it's still an equation. We're now going to factor this, which we already did, and we say now this equals a negative 25. We take the square root of this side, plus or minus the square root of that side, excuse me. We get x minus 6 equals plus or minus, now this is an imaginary number, 5i. We then transpose our 6, and we get x equals 6 plus or minus 5i. 6 plus or minus 5i. And as I mentioned, they gave you this one, but that's the wrong sign. And these aren't solutions here. Okay. Now, for this one, you have to read it carefully. It says a ball is thrown downward from a window in a tall building. So let's make a picture. So there's the window up here, and the ball is thrown down. The distance traveled by the ball in t seconds is this equation, which is s equals 16t squared plus 32t to t, where s is in feet. How long to the nearest tenth? So they're telling you what they want you to round it off to. Will it take for the ball to fall this many feet? Okay, so our s here we can change to 195. And now this equation we can change by bringing this over to the other side as a negative 195, and this will be a 0 now. So we've put that in standard form. We now identify our A, our B term, and our C term, which includes the negative. So we put it in the quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we have to take our a value, our b value, and our c value and put it into the quadratic formula. Okay, so again, on your paper, you have this. If you want to make a picture, that even impresses me. That's good. But there's your quadratic formula in standard form. Well, your quadratic equation in standard form, in which we identify the a term, the b term, and the c term. And now we put this into our formula. Negative b is 32, so a negative 32. Now I eliminated the negative here because we're going to get positive time. So we're not looking for a negative answer here. Plus 32 squared minus 4, which is in the formula, 16, which is our a term, and a negative 195, which is our c term. Now notice we have two negatives here, so all of this is going to become a positive. So what I would do is calculate this, which is what I'll do, and I'm working with my calculator here carefully. I take the square root of this, and I get this big number here. I subtract 32 from it, and I get a value, and then I divide it by 32, and I end up with this, and it's more decimal points. But they want us to round this to the nearest tenth. So we look at our hundredths place, then we're going to just drop this. We get 2.6, which happens to be right there. Now again, we're showing lots of work, and again, show the work. And you're going to use your calculator, of course, to do this computation. Now we're going into Module 6 material. I believe these are the remaining questions, where we're doing composition. And we want to have G composed with F, where our value is X. So let's do that. Now I was checking some of your Module 6 tests, and a lot of you were getting these incorrect. I think part of it is you didn't come to the lecture and may not have known how to do them. But again, it's not too late yet. You're preparing for your exit exam. So it's G composed of F, and we're looking for the X value. Well, this is our X value here for F. So we take all of this from F and put it into our G value. So where is the X in the G value? Right there. So we're replacing this where the x is, which is what I show right here. This is our x. So we distribute, get this, we're including the 5. So we have this plus 5 here, gives us 19, which is the first one. Again, your practice and quiz me, and then later your test, your modular test, is what is helping to prepare you for this one. Let's go on. Well, for this one, again, this is chapter or module 6. You wanted to see if this is a function. They are saying it's a function. Is it a one-to-one? Well, let's see if it passes the horizontal line test. Now we could rewrite that as y equals 8/9 x minus 5/9. So that would be our equation of this in slope-intercept. So when we make a graph of this, this is just going to be a sketch here. Our y-intercept is a negative. We'll make some big lines here. So this is going to be a negative 5/9. It doesn't have to be too accurate, which is right about there. And our slope is over 9, way out there, up 8. So it's going to be a line that looks somewhat like that. That's what this is. Now, does this pass the vertical line test? And the answer is yes. Now, does it pass the horizontal line test? And the answer is yes. So they are saying it is a function, and we have to see if it's one-to-one. That's the horizontal line test. It does pass it. So yes, this is one-to-one. So if it is one-to-one, what is the converse or the inverse of this? And the formula for inverse is, again, I would write it like this here, or you could write it this way too. Let's use this one here. Different ways to do it. So we're going to convert this to a y and just write this. So that's exactly what we had here. We're just doing the first step of finding the inverse, converting the f of x to y. Now what we do is we exchange the y and the x. So this will become an x, and this becomes a y. And now we solve for this y. Okay, we're going to do so by multiplying both sides by 9. So in this form it's actually a little better. Here the 9's cancel out, and we get 9x equals 8y minus 5. We now take our negative 5, bring it over. We get 9x plus 5 equals 8y. And now we divide everything by 8. And how do they want it? All over 8, maybe, like this. So this is our inverse. Y, which we change back to f of x, but in its inverse form. So it'll be f inverse equals 9x plus 5 all over 8. So all of these are that way. 9x plus 5 all over 8. I think we, since this is now bigger, we missed it. The answer is going to be right down there. F inverse, I'm going to put the 1 there, of x is 5x plus 5 over 8. Okay. And that was the work. And that was the answer right there. Okay, we have this a little bigger. Let's make it a little smaller so it fits there better. There we go. All right, they're asking us now from this expanded sum of logs to express as a single logarithm and, if possible, simplify. All right, let's work on this one. Now, since I'm doing this for the first time here, I kind of worked it out a little bit. But as I look at it, we need log C, which is our log C right there. Now, M minus N indicates division. The minus indicates division here. And in this case, this is also multiplication now of K, and we take this up to where it belongs, the 6th power there, and that's our answer. And there it is right here. Now looking at some of the other answers, here they didn't move the 6 up there. And here they have it in the denominator, which it doesn't go, since this is plus, indicates it's in the numerator. So again, not a lot of work to show here, but I would at least write this out. That indicates you did the process, and then you picked out your answer. Okay, let's go on. Just 2 more. And we went over this in our last class too. This one's sort of an easy one because as we look at 64 and our base over here of 4, we can do immediate conversion. So we have 4 to the 1 plus 2x power equals, I'm going to make this a base of 4 also, to the 3rd power. And the rule was, if your bases are the same, then your exponents equal each other. So we transpose that. On this side it becomes a -1, and we get x equals 1. And it looks like right here. All right, now for our last one. So this is in its logarithmic form. And as we said in our last class, we want to convert it to its exponential form. So as we convert this now to exponential form, what is our base? Our base is 4. What is our exponent? Our exponent is 1. And what is our answer? Well, it's this, which is a binomial, in a sense squared, which is x squared minus 6x plus 9. I'm just foiling this to get this. Now to put this in standard form, I'm going to bring this to the other side, so I get 0 equals x squared minus 6x, and this to the other side makes it a negative, or I should say a positive 5. Now I believe that's going to factor. So let's give it a try anyway. Yes, it will. X squared Well, let's go for x and x. 5 and a 1. When I FOIL it, it checks. So we then get x here equals 1. Here, x equals 5. Now, notice they don't give these two answers. So, what's going on here? Well, if we go with a 1 up here, our x is 1. This is negative. And we said logs of negative values are undefined. So this is not a reasonable answer. So the only answer we have is 5. Now, since the 1 isn't there, you have no reason to pick this other one. Okay? So this would be the work, and you've done this, and hopefully you get 100% on your exit exam. A couple of people that took it did in that early test, and good luck to you.